Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I'm Michael, founder of pgMustard. This is my co-host Nikolay, founder of Postgres.ai. Hey Nikolay, what are we talking about today?
Hi Michael. Last time we talked about read-only state of read-only workloads and the case when we have data not changed for significant periods. So how can we adjust everything for such kind of workload? Let's talk about different case to extend this discussion. Let's consider the case when we change things very quickly, and particularly let's discuss the idea of using Postgres for queuing or message system. Like we have some tasks, we need to process them and consider being processed and so on. So instead of using things like RabbitMQ, Kafka, Sidekick or something like that, let's consider having similar thing right in Postgres.
Yeah, I hadn't considered that about it being nearly the opposite of last week's episode. But yeah, we there was a popular discussion on Hacker News very recently on this, and
it's not only popular; it's one of the most popular topics related to database in general. If you check how many times it was, like every backend engineer, I think, experienced backend engineer, implemented this on their own. Like queue in relational database.
Well, it feels to me a little bit like the MySQL versus Postgres thing, right? It's like people comparing, people kind of having strong opinions one way or the other.
Or stored procedures.
Yeah, exactly. It's one of those things that there are good arguments on both sides. Should we even use a relational database as a queue? If so, why? Like when? And if not, like what's the which of the it doesn't tend to be which of the various queuing specific services to use. It seems to be much more of a holy war between should you use a dedicated queuing tool or can you get away with putting it in a relational database?
Yeah, there are two big camps here. Mm-hmm. But I would say if you cannot stop people from using ORMs or from using stored procedures, and in my opinion, queue in Postgres is absolutely nice and good idea if it's implemented correctly, and if it's ready to scale, to grow, to handle performance aspects, and if like it's not a bigger sin than using stored procedures or ORMs, maybe smaller sin, right?
Yeah. Do you see? Are there exceptions? Or in fact, actually, let's get into that a little bit later. What? Why do you, or when do you see it most commonly used as a queue in Postgres? Like, are there any people you're seeing doing it in a great way, or like which? Actually, let me rephrase that. Do you want to talk about like why we'd use it versus a dedicated
let's talk about why.
Queuing tool?
When we develop something, at some point we need some queuing mechanism or like message delivery system, message bus. There are differences, there are differences in terminology here, but it doesn't matter. We have some signal. We need to propagate this signal and we need to process it asynchronous. Asynchronous is the key word here. Yes, asynchronous processing. And latency should be small. Throughput should be big, large, should be good, and that's it, right? And in some cases,
maybe like exactly once.
There might be multiple consumers. There might be cases when we want retries, when we want a reliable delivery of any message, and so on. Like obviously, like many requirements that are set. But the question is, should we start using a special tool separate to our relational database such as Postgres? Or we can use Postgres itself, for example. And you cannot stop people from using Postgres, first of all. I observe it, first of all, I did it myself. And eventually, quite quickly, I switched to pgQ from SkyTools. It was very good in terms of characteristics, but it required some maintenance. And you cannot use it on managed Postgres unless it's directly supported, because it requires additional workers next to Postgres. So you need you cannot use it on RDS, for example, right?
Yeah.
But I liked the idea to be inside database due to a number of reasons. We will return to them. But then in my career, like consulting career, a lot of consulting practice, and also startup guy career. So I have two things to notice. One, quite often you come to some database trying to help them work with Postgres and see hotspots. And sometimes, quite often, one or a few hotspots is some table which is having queue-like workloads. And it experiences a lot of bloat, sudden degradation on performance, and they ask you to help. This is very, very common request for any consulting DBA. I think, like with experience, it's very, very well-known situation, which is a sign that people try to keep it in the relational database and have problems. And this is, of course, cons item, right? Because it's not, if you do it straightforward, in a straightforward way, not thinking in advance, you will end up with this hotspot in terms of performance issues. And then, on the other hand, every few weeks on Hacker News and all other places, we see a discussion, right? So many discussions, like new tool to implement queue in Postgres, or we replaced RabbitMQ just with Postgres. This tool, that tool, for Ruby, for Python, anything. Like so many tools. So I even remember how I helped like 8 years ago or so. There is a small library called Delayed Jobs. Ruby guys should know it. It's quite old. And I just, like, instead of, like, I found my clients using it and complaining, like, it doesn't handle our load. You just check into the code, check to pgStat statements and understand, like, two simple actions, and it can scale 100x. I even opened pull request in their GitHub, but I think they still didn't merge it, saying we need support to support MySQL. That's why this, like, I don't know. But I had a lot of thumbs up from people who found how to improve performance of delayed jobs library. And we will talk about how to make it right. But back to the reasons question. Why inside database? Obviously, you don't want to manage yet another system sometimes, right? And then one more thing, it's ACID principles, right? We want
transactions,
atomacy. Exactly. We want atomacy, and this is probably one of the brightest reasons here. And we want, of course, backups, like HA characteristics and so on.
Crash recovery, like
many things, like right, isolation, like many things. Mm-hmm. And Postgres can provide many, like Postgres covers in a very good way many requirements we might have. And for example, if you work with some system, if you have monolith or it's a microservice and you need something internally, because we need to distinguish situations when we need the queuing system inside something, or we need it as a mechanism to communicate between two services, for example, right? But if it's inside, you have transactions, you rely on transactions. Of course, you don't want RabbitMQ, for example, or Kafka to have inconsistent data, right? For example, we commit a transaction, but then we started to write to event to our external additional tool. Somehow we didn't accept writes, inconsistency. Or even worse, we had transaction. Inside transaction, we wrote to Kafka, and then we had rollback. Now we have event which should not be there. Again, inconsistency, very not nice situation. But you know what? People solve this. There are microservice patterns, right? And it's called transactional outbox. Let me explain. It's very simple idea. I'm quite sure I implemented myself it several times, but people gave it a nice name. Those our listeners, by the way, don't forget to subscribe and like and share. those our listeners who are backend engineers probably know it, this transactional outbox, especially if you worked with microservices approach. So when you inside your transaction doing some things and you need to create a message, you just write it to a special table, this like outbox table. You write a row, you commit, everything is good, right? And then later consumers pull this message and deliver to your messaging system outside of Postgres. Can be again Kafka, RabbitMQ, anything, Sidekick, many systems, right? And mark as already delivered, right? It can be in batches somehow, asynchronously. You can speed it up with various ways, but in this case, you have guaranteed delivery and eventually consistent state, which for microservices is quite good. It's very simple idea, and it works.
Right. I do think you're right. I do think the ACID performance of Postgres, or the strengths of Postgres there really is the main reason that it should be chosen. But I think the main reason it is chosen in general is actually the other one. I think it's the simplicity angle, or not having multiple, like people are familiar with it already, not having to learn a new system, not having to do backups of another system, not having to do ops on another system.
It doesn't crash as often as RabbitMQ does, right?
Yeah. Well, people, I think quite a lot of the time I'm reading these blog posts, and at least in the comments, people are suggesting, it isn't that tool is necessarily bad. It's that there's that the people writing the post didn't know about one feature in it, or didn't know how to overcome a certain issue, or they were holding the tool wrong. So it's not necessarily that you can't do those things with those tools. It's more that you have to learn them. You have to get good at them. And it's that takes experience and time. And why do that if you've already got a perfectly capable tool, even if it's not the perfect tool, perfectly capable one in your back pocket that you already know? Right.
Yeah. So the reasons are obvious, and I myself, I work with all systems in both camps, and sometimes there is a mix actually. But I'm definitely, if I need to choose, I myself belong to the camp which says it's perfectly okay idea to have database right inside, to have queue, right inside Postgres, but you need to take care of a few things. Just a few things, actually two things, that's it.
I'm going to interrupt you because I actually was going to ask you this later, but I'm tempted to ask you it now because I think it will be interesting. Do you think there's a scale at which you would stop saying that you should use Postgres for queuing, or is it as scalable as other solutions?
Definitely. There is, we consider a regular Postgres approach with single primary node. So there is definitely the ceiling when we saturate our CPU or disk IO with writes. And this write workload cannot be offloaded to standby nodes. So we need multiple writer nodes or multiple primary nodes. At this case, you need to either scale using Postgres in one way or another, probably sharding or something else. But microservices approach minimizes this need. It postpones it very well because you need like if you split vertically to services, you need one of the services not to be able to be split further, and you need it to be so big that you already need sharding, right? So you need either to scale somehow to have multiple primary nodes, or you need ready to give up and say, okay, enough. Inside Postgres, we need to offload it. But this moment will be so far from the beginning. If you have, for example, modern Intel or AMD EPIC third generation, Intel is like 128 vCPUs, and any big cloud provider can provide it easily. Or these EPIC processors, 244 vCPUs. You can scale your writes really, really well. Like you can have dozens of thousands of writes if they are quite well tuned, and you are okay per second. I mean,
Yeah, I was just going to check for
per
yeah,
second.
makes it
Of course.
per day according to some of the Hacker News.
Per day, it's so like you can handle billions of writes per day on one node.
Wow.
Yeah, it's definitely possible, but you will need to take care of several things. I said two actually. I have three already items. Usually, I always said like, okay, yet another article is popping up on Hacker News top. Like we had it last week once again, right? And my regular checklist for such articles or new tools does it use for update skip locked? And second,
that was a huge change. That was a huge improvement, wasn't it?
No, I will explain why no. I'm about to exclude it from my list. I will.
Okay.
Let's discuss it. But normally it's in the list. But in my opinion, it's overrated. Well, like there is a spiral growth, right? When you have experience, you think, wow, this is super important. When you have more experience, you think, well, it's overrated. It's not that important. There are more important things. So, okay, for update skip locked, let's keep it in the list for a while. Maybe we'll remove it in the end of our discussion. Second is how people address dead tuple and bloat issues.
Yep.
Right.
Huge. So, that's the one big downside, I'd say, of the Postgres.
Right.
So yeah, that's that. Obviously, locking is important, and we should talk about how to avoid, locking hotspots. And bloat seems to me like the one that not many people talk about, and not many of the tools solve for very well.
If people don't talk about bloat when talking about queue-like workloads, they do poor job. I mean, in Postgres. This is poor quality material, because this is actually number one problem. When you grow, because how you handle already processed rows, dead tuples, like we have high churn system in this case, right? We have something which expires very quickly. We processed it, we need to get rid of it. And Postgres MVCC is very well known to have issues in this area. Dead tuple issues or bloat issues as a consequence of dead tuple issues. And how you handle it defines your limits, basically. And when you defines how fast you will start having performance issues in your system. Okay.
I feel like the locking discussions. Oh, sorry.
Number three. Let's frame our plan of discussion. Number three item is your queries and how efficient they are, how many buffers they touch each time. Right. So if you check explain analyze buffers, we want as low buffer numbers as possible.
Great.
Hint index only scan. Right.
Yeah,
obviously.
I'm gonna suggest we talk about bloat first, because I feel like the locking one's gonna get a little bit subtle, and I think it'd be nice to have had the bloat discussion already, because I think that's gonna play into it, and then maybe do the query performance thing as like a tuning thing last. What do you think?
Yeah, well, bloat is the number one question for me, these days at least. Like, if you asked me 5 years ago, I would probably start talking about... you see, I started with skip locked first.
Yep.
But it's already quite advertised. So everyone knows about skip locked. We will return to it and discuss why it's not number one anymore for me. But why bloat is number one? It's because this is where you will have this hotspot issue. This is exactly when performance will start degrade very quickly. And for example, if you question is check your pgstat user tables and check tuple stats, how many inserts, deletes, updates you have. And of course, a lot of inserts, it's like we have incoming events. But then what do we do with these tuples? Do we update them or just delete or both? And what's the ratio here? Looking at this ratio, we understand our pattern, right? And each update physically consists of delete and insert. We know it. Even if I don't, I'm not tired to keep talking and reminding this. If you say update my table, set ID equals ID where ID equals 1, you will have new tuple. even if logically you didn't change anything, right? So it produces new tuple, marking
And
old one
worse.
as as deleted first. Not
Yeah. And worse, may update indexes as well.
well, yes. So it depends. Hot updates
I know.
are smarter a little bit since we didn't actually change the value, right? So probably this update will become hot, but it depends also if we have space in this same page of a heap
Even
page.
if that's an index column, that's cool if it does that. I didn't realize it did.
It's okay. ID column is primary key probably, right? It's our surrogate primary key, but we didn't change value. I believe I'm not 100% confident here. Worth checking.
Yeah,
But
let's check.
But I believe since we actually didn't change the value in this, like idle update, right?
But
In this case, hot update might happen.
But my main point is that updates in general can we have the right amplification problem as well as just the new tuple in the
I might be wrong, and hot update might not happen even if we don't change. But even if I'm right, in some cases we still won't have hot update. For example, if there is no more space in the same page, we need to go to another page. In this case, definitely we will have write amplification. All indexes that the table has will need to receive these writes, and all these writes will go to wall. It will go to backups. It will go to replication. It's like amplification of writes, actually. Write amplification. That's why the name, right? And it's a lot of overhead. So why I'm talking about this? Because in the queue approach, like what do we do with our record? We probably mark it like status equals processed,
or delete
changing from pending, or deleted, like soft delete. Like we don't actually row exists, but it's marked as deleted, right? Or like from pending to retry to process something. We have some status or something, right? Or we can just directly delete it, right? Also.
Yep.
But updates will produce deleted dead tuples, and delete will produce dead tuples. And if we go very fast, and we want to go very fast, we will end up accumulating a lot of dead tuples. And then the question, will AutoVacuum be able to catch up and not, like if it's with default settings, it won't be able to catch up, right? And we will accumulate a lot of dead tuples, and then AutoVacuum will delete them, convert to bloat. Right? AutoVacuum is a converter of dead tuples to bloat, right? In most cases, I'm joking, right? But in most cases, it's so, because we already created new pages, and if AutoVacuum deletes dead tuples not in the end of table, it cannot truncate this page. It will keep, maybe whole page will be empty, sitting there, just contributing to bloat. That's it. And then
I think this is slightly counterintuitive though, because I think some of the like AutoVacuum settings, for example, are scale based. So, for example, because we're dealing with a queue, like a queue table of only unprocessed rows, or I'm assuming you're deleting them, you might think that even if it's a bit bloated, it's not a big table still. But if we're talking about the case where we keep them around, or a case where we have a bit of a runaway queue for a while, or, in the case of an issue, this can quickly happen and crucially is not undone. So each time we get an accumulation, we'll accumulate more in future unless we have a strategy for over time getting rid of that bloat.
Right. Well, yes. But also, don't forget that some long transaction might happen, or on standby reporting via host standby feedback being on, and preventing AutoVacuum from deleting the tuples. It says I found the tuples, but I cannot delete them because probably some transaction is still needs it, and it's a global problem. So it keeps them and then again converts them to bloat. And this is exactly a hot spot I mentioned. This looks like we have 1,000 live rows, but the table size is 10 gigabytes. You say, what? 10 gigabytes for 1,000 rows? What's happening here?
Yeah. I did.
But-
I think you shared with me that there's a really good blog post by Brander about this specific issue. They argue at the end that that's a really good reason to not have this in your main database and have maybe a separate. But that's my interpretation of the argument.
Good post with wrong conclusions.
Oh, interesting. Great. Okay. So,
Well,
what
you
can we do instead?
We can do like insane but quite reliable way. You just put vacuum full to cron. Why not?
No.
It takes a second. It blocks everyone, but inside the second, you have fresh state.
Well, I guess it is a queue, and therefore, what's the worst that happens in terms of things are delayed a little bit? But you can't
I must
insert
admit,
into it.
I
You're
never
joking,
did it
right?
for serious clients, never did it for serious clients, but I consider it as a valid idea in some cases. If you need to like stop this fire, stop this hotspot from happening, just put it as a very fast and like quick and dirty mitigation approach, and it will help. This like a latency spike of 1 second for all those who work with this table, it's not a big issue compared to constant pain they feel from degradation related to bloat and dead tuples. By the way, dead tuples themselves can be a problem. For example, when you delete in batches, you do everything right, but and you have index-only scan, and then you start noticing that index-only scan, even if it deals with same number of rows, somehow deals with more and more buffers. Why? Because it scans through all those dead tuples all the time. And solution to that, by the way, also like probably vacuum is one thing, but probably in some cases solution is I like idempotent queries. I'm big fan of them. Idempotent queries, they like find me next 1,000 of rows to process and delete. Or just delete. Sometimes we just need to delete, clean up job, something. Like find next 1,000, delete. Find next. I don't care. I have reliable way to order them. I have indexes, all good, index only scan, but somehow then more and it degrades over time, and you realize AutoVacuum cannot catch up, and you just keep scanning through all those dead tuples. And the solution is to introduce context and move away from idempotency. Just remember last ID, for example, or something timestamp, and start from there. You skip all those dead tuples. But
I saw, I saw, the idempotency thing's an interesting one. The key, I saw somebody discussing using keys and then maybe they called it some kind of jitter to make sure that if for example, everyone had skipped, so maybe we'll get onto this with the skipped locks. If, for example, all workers had skipped ahead and there was a job left behind that number, or behind that date, or when like an old job, so that you might have to sometimes forget, like one of your workers maybe forgets its latest key context every now and again, exactly,
Restart,
to go back and fetch some old, exactly. So I think there's a little bit of extra engineering needed if you go that route.
Well, yeah, but at first run, it will scan through all the tuples, and then it will keep remembering the position, for example. It depends. I'm still a big fan of idempotent queries. I like them, I do. But sometimes we need to, we have trade-off here, right? But we didn't discuss the main solution to bloat.
Before we do, quickly, vacuum full, what happens with indexes?
Rebuild.
They rebuild, okay.
Yeah,
it's and like because it's a small amount of data.
We can run pgrepack against table and all its indexes. It will be the same. It will be better, of course. And people do this actually, but vacuum full works.
But there's no point because we have a better solution that you're about to say.
Well, repacking is better than vacuum full, of course, because it will lead to very brief period of exclusive lock. Right, so very, very brief, and it's very graceful and so on. Vacuum full is a big hammer, of course, like a boom, and we're good again. So pgrepack is a valid solution for those who want to get rid of problem and continue working as nothing happened. But if you want to design the system to scale for really good, like TPS, transactions per second, and with low latency, and handle a lot of events per second, in a reliable way inside Postgres, you need partitioning, right? You need partitioning, and a good lesson can be learned from pgQ, from Skype, as I mentioned. It existed like almost 20 years ago. When
Yeah,
Skype,
this is super cool. And I hadn't even really thought this through, but they can't have been using for updates skip locked for it because it didn't exist then. It was skip locked was only introduced in 9.5.
Well, advisory logs probably already existed. I'm not sure. I don't remember. But we didn't start talking about how to improve throughput. So let's return to skip locked slightly later. I'm talking about bloat and dead tuple issues.
And right, and they had
solved
partitioning.
Exactly. Yeah. Declarative partitioning didn't exist at that time, so they used inheritance-based partitioning, 3 partitions and rotation. Right, so we use one partition, we maintaining another one, and third one is like on idle. And maintaining means like we just truncate.
Yeah. So wait,
truncate is
fast.
It
that I was trying to work out why there are 3? Is it that we have one that new rows are going into currently, one where we're trying to finish the final jobs in it, just while we're switching between partitions, and then the third one that is always
honestly,
going to be ready
I don't remember. I remember
okay.
I used it, and I actually applied similar approach in different systems because it's a very smart approach.
Yep.
Skype had a requirement to handle billion users. So they designed very good system here. And it's still alive, by the way. It lacks good documentation probably, but I asked people about queue in Postgres, and I was super surprised. I'm checking numbers right now, more than 105 votes on Twitter. I asked on LinkedIn as well, and 7.6%, so maybe it's like eight people around there said, I'm a pgQ user. So big respect. pgQ is great still. Like you need to cook it, of course, right? But it's enterprise level solution. If you manage to work with pgQ, you can work with very very large volumes of events per second, low latencies. You're in good hands, right? But nowadays we have declarative partitioning, and for example, timescale also helps automate it. And I wonder if there are around people who implemented a good queue system based on timescale. If there are such people around, please let us know. I would like to learn because I have similar situations in my area as well. And I think it's so partitioning gives you ability, gives you benefits. We discussed benefits from partitioning, but here most benefits are you can like divide and conquer, right? So you have partitions which are already fully processed. You can just drop them, right? Get rid of them.
And that's important because whatever bloat they've accumulated during the time that they're that's all now gone.
Right. So instead of fighting with bloat, you just forget about it, get rid of it, and that's it. But of course, you need to design it in a way that it's not like we work with all partitions all the time, right? So you need to have some partitions which already fully processed. So you need to consider them as like done, and you just drop them. Or you can implement some rotation with truncate. So you truncate actually recreates file. And you have fresh state again, like 0 rows, indexes are empty, you start from scratch, 0 bloat. So this is ultimate solution to bloat. Just get rid of it fully inside table. And partitions, it's a physical table, so like we can do it. And also, of course, it gives you data locality for it, a lot of benefits. So you can keep old partitions for quite long, even if they accumulated some bloat and so on. New partitions don't see them, and they don't suffer from issues old partitions have.
Yeah, the main benefit is very, very simple and easy bloat management.
Right.
Cool.
So, right now, for update skip locked.
Yes.
It's a very cool feature. But it's needed when one worker is not enough, right? And in some cases, it's enough, because
that's a really good point. Yeah,
it's related to
cases.
third question. Let's talk about. I'm trying to downvote the importance of skip locked, and I do it by purpose. Yeah. Let's discuss query performance. We've already touched this a lot of dead tuple accumulated case, right? But in general, the advice is try to have index only scans. Here, AutoVacuum should be tuned again, because we want heap fetches to be as low as possible, ideally 0 all the time. It's not in practice, it's usually not 0, but we don't want like index only scan. It's good when it's like when have heap fetches is close to 0, because in this case Postgres executor doesn't need to consult heap. If it does need to consult heap, it's similar to index scan already, right? It's so degraded index only scan is index scan. Right. So to have real index only scan, we need to keep AutoVacuum quite aggressive, to keep visibility maps up to date, to know which pages are marked all visible. So if they are marked all visible, index only scan can avoid consulting to heap and deal only with index. And to achieve that, sometimes we need to use covered indexes, so include additional columns. It depends. Right.
Yeah, or even in later versions of Postgres, I don't think there's that much benefit of the includes. I think if anything, there might even be benefit of not using it because of the deduplication.
Advice is to consider Postgres 14 or 15.
Yeah.
14 is great. 13 was good. 14 is great already. The B3 deduplication is great. It helps with bloat as well.
But I think it only deduplicates on ordered columns, though, not on includes, for example.
There are several things there. But
okay, never mind. It's a minor point, but index only scan. So is this for the update query? Like which queries
for
is
selects,
it?
For queries like find next item to process, or multiple items, right? So. Yep. So these kind of queries. And of course, as for updates or deletes, if we deal with updates, we want to try to make them hot, heap-only tuple updates. To do that, sometimes I see people consider reducing fill factor even for tables, which is 100 by default, so they reduce it for like 50. So let's have room in each. We have artificial bloat initially, like 50%.
I don't mind it, yeah.
But our updates are faster. If we set status equals processed, most likely it goes to the same page, no index amplification, it's good.
And you probably then can't or don't want to index your status column, for example.
Right. Well, yeah, it depends. But yeah, we need to take care. We need to be careful. Sometimes we try to avoid additional index because we know we will be updating for status, for example, right?
Yeah.
And we know, like, okay, how many rows with these like parameters will have status, like multiple statuses. Maybe no, like let's not have status in indexes, for example. And in this case, but because if you have status in indexes, in any of indexes, even if in where clause in partial index, and then you update status to something, of course, this update cannot be hot anymore. So that's
exactly.
it. So it's full-fledged update having all right amplification, right? So speaking of query performance related to our workload, we need to we probably can divide it into two parts. First, the task of purely select, how to find next row to process or batch, right? The index only scan should be there. And second, write itself. It can be update, it can be delete. Well, insert also interesting, but I hope insert is quite fast usually. Maybe also worth checking, but usually it's like number 3 item probably. So update, it's good to have hot update. Delete, what can we do with delete? I don't know. With delete, we just mark it as a dead tuple. That's it. So yeah, well, sometimes also people like to have returning to send
get the IDs
result to application code. also handy. Sometimes people like to have multiple stages and write CTE, combining maybe updates, delete, something like in single query, and this reduces round trip time. So in one query you can do multiple things all together and in single query from application code. But overall you can reach it's good if your selects are much less than 1 millisecond, even if you have a lot of rows. Our queue table usually doesn't have a lot of rows, right? Especially if it's partitioned and so on. And for write operations, 1 or a few milliseconds is a good performance, usually, right? If it's more than 10 milliseconds, I would doubt it's good, right?
Well, especially because we're talking about updating only a single row in general.
Yeah. Well, yeah.
So it feels like we need to talk about the
it's time to talk about skip locked. Okay, now we see, for example, our write operations take 2 milliseconds. It means that we cannot process when we have single worker. It's always latency and throughput are very well connected, right? Mm-hmm. It's like you have a second, 2 milliseconds, 50 operations per second only. This is our throughput. If it's not enough, okay, let's have multiple workers. We might have multiple workers due to some different reasons sometimes, right? Because just one worker does this, another worker does that. I don't know.
Yep.
But if it's for throughput, we must understand that they might conflict. They will conflict eventually, right? And if one we cannot update same row at the same time twice, right? So if one is updating until the very end of transaction, commit or rollback, exclusive lock will be on this row, right? And another worker will be just waiting on it. It can be seen in wait events analysis very well. In this case, we can use for update no wait or for update skip locked. No wait will just fail, like you fail fast and retry, startup approach, right? So, or skip locked, give me next row or few rows.
Yep.
Batching also interesting topic, by the way, but we don't have time for it, but yeah. So,
and not that interesting, I think. Like it's interesting, but not super. Yeah.
If you handle dead tuples and bloat very well, if you have tuned queries and you know that your queries will be always quite fast, you probably don't need multiple workers. But of course, if you need multiple workers, go ahead and use skip locked. But remember, if you, for example, use Django or something, and sometimes sub-transactions might pop up. And for update skip locked, if you have sub-transactions, you might have issues on replicas so go and read my article about sub-transactions. There are dangers there. So regularly select for update is okay. But combined with sub-transactions, it's not fun. But in general, it's a good thing. By the way, someone on Twitter mentioned also the problem when the executor needs to scan over a lot of rows which are already locked. It's a similar problem as we discussed with dead tuples, right? So we have a lot of rows already locked, and trying to find unlocked ones, we have degraded performance as well, right? But I think it's kind of edge case maybe.
I think so. It'd have to be you'd have to be doing things in batches and maybe have lots of workers before I could see that becoming a big issue. But yeah, definitely can see how it would happen at scale.
Yeah. So that's it. And if you have multiple workers, you definitely can achieve many thousands of transactions per second on good hardware, of course, and maybe dozens of thousands of transactions per second. That should be enough for most systems already these days. Right?
99.99%, I think. Yeah.
Well,
obviously
there are cases when we need more, but this is already good enough thing. And so summary is bloat is our main enemy here. Dead tuple and bloat, and partitioning.
Consider partitioning, yeah,
with proper rotation or partitioning strategy, right?
Yep.
Second is check, explain, analyze buffers. And have good plans for your queries. and only finally for updates keep logged. And if you see some tool which addresses all of these things, surprise, only PGQ does it.
And I'm not even sure they use the latter, so that's
so many attempts to implement it, re-implement it. And when I say, guys, what about bloat? To-do item. So if you if you find the tool which addresses all these three things, I don't care about language. Please tell me.
Nikolay,
I will advertise it, yes, because I see dozens of attempts to implement queue in Postgres, but these guys fail in these three areas. They sometimes implement skip logged, for example. It's very well advertised, as I mentioned, but they fail to do bloat part, or some indexes are not well organized.
Wonderful. Okay. Well, thanks so much, Nikolay. Thanks everyone for listening.
I do hope we helped some queue builders,
for sure.
queue in Postgres builders, because we need better tools. Or maybe some people can resurrect PGQ in terms of provide it as a service. Why not? Some managed Postgres providers.
It would be good if some managed Postgres. I know they'd have to install something else, but I think it would be popular
if it's just one click.
The daemon, right? Anyway, thanks everybody.
Good.
Thanks, Nikolay. See you next week.
Bye.
Bye.